on, let's talk half angle and reduction. We'll get through these, and that'll be the end here. Your proofs. I'll actually get into the stop. Double angles. So we got last time that sine of 2x is equal to 2 times sine of x cosine of x. Actually, I used thetas with you before, but now I'm using x's, so you get used to seeing different pictures on the side. But what we're going to talk about in this one is actually cosines double angles, and in particular the two bottom ones. We're going to use these two that are on the bottom, this one and this one, and it's going to help us define what's called the reduction formula. Really, all we're going to do is solve for sine squared, and we're going to solve for cosine squared. There's a reason. I'm going to show you, give you a little preview. If you end up in, say, a calculus class, you might see weird symbols like that. This is just notation. And inside, you have a sine squared. Now, you don't have to understand what I'm talking about. I just have to tell you that this thingy doesn't play well inside of this. We have to change it. We can't ever have squares on top of sine or cosine when we do this weird mathematical hieroglyph shit in a Calculus 2 class, or maybe a Calc 1 class, or a Calc 3 class. But there's a reason why you want to know this, because down the road, if you're one of those students that's going there, you might need it. And if not, I'm sorry. I use this as an example. I had to take dance appreciation. I'm a math teacher. Life isn't fair. All right, let's get it. So we have cosine of 2x is equal to, and let's start with this one, the 2 cosine squareds of x minus 1. Now all we're doing here is trying to solve for cosine squared, and we're going to call this the reduction formula. That's what we're going for, is these reductions. It's a power reduction, and you'll see why. So let's add a 1 over, and I'm going to put the 1 out front just because 1 plus cosine of 2x is equal to 2 times cosine squared of x. And now we're just going to divide out the 2, and we're going to be done with this. And what we can actually say now for our reduction formula is cosine squared of x, right here, now that canceled out, is equal to 1 plus cosine of 2 times that x over 2. This is a reduction formula, or a power reduction formula. So let me write this at the beginning of this. Power reduction. And why do we call it that? Because look, we can take a cosine squared. We can take that cosine squared, and everything on the right-hand side, hey, that's money. None of it has a square on it. That weird little symbol I showed you at the beginning, well, it can handle that. All right, so in the last one, we used this formula here. Now, let's use this one. We'll go, all right, let's go find it. So we want to find cosine of 2x is equal to, we're using that one, so 1 minus 2 sine squareds of x. We want to solve for sine squared. So I'm going to subtract the 1 over, and I'm going to write it in a weird way. Negative 1 plus cosine of 2x. I'm trying to follow a pattern. And now we have negative 2 times sine squared of x. Although, shoot, we got to divide, we want to solve for sine squared, so we divide by negative 2. Ooh, there's a lot of negatives there. Our sine squared of x is equal to, now, do you mind, can we just take this negative and just travel it up here? Because you know it doesn't matter where the negative is, correct? That negative could actually just be right up here as well, and we could just bring it in. Changing that to a positive 1, changing that to a negative cosine, and now we have a positive 2 on the bottom. Hey, there's sine's reduction formula. So let's put it right near, cosines. See if you notice anything. Let's see if we notice anything. Do they look familiar at all? Do they look similar? Sine subtracts. Cosines doesn't. So sine squared is 1 minus cosine of 2x over 2. Cosine squared of x is 1 plus cosine of 2x over 2. Cosine squared has a positive, sine squared has a negative. That's our power reduction formula. More games on that to come. Now we're going to play a game where we're going to want to find a half angle. A half angle. We're going to create another formula. And all of this stuff is coming from that initial sum and difference formula. Builds everything. So I'm now going to use the power reduction formula to find out the half angle formula. Because we're almost there. We want to find half an angle. Now we want to know our half angle formula. So we have a double angle, we have a power reduction, and we got a half angle. So you know what I mean? Like half an angle. Alpha over 2. Alpha over 2. Isn't that half of an angle? But what I think we should do is we already have these power reduction formulas sitting over here. Let's see if we can't play a quick game. Do you mind if I call that alpha over 2? We're saying half an angle. Let's just call that shit x. Just call it x. You know, just call it x. Just call it x. And then, oh shoot, we better figure out what 2x is. So you mind if we multiply both sides of that thing by 2? So if you multiply both sides, so you get 2 times alpha over 2 is equal to 2 times n. Oh, alpha is just equal to 2x, because we multiplied it by 2. Wait, let's plug it in. Let's take that and let's put an alpha in there. Over here, let's put an alpha over 2. Let's see what happens. Let's see, we got cosine squared of something is equal to 1 plus cosine of something all over 2. And then we're going to do our replacements, right? What's in purple? So instead of writing in x, we said x was equal to alpha over 2. So we're like, all right, alpha over 2. And then we're like, okay, and then 2x, well, that's just equal to alpha. Oh, shoot. And we want to know half of an angle. Half of an angle. But we want to know it for cosine and sine. So let's hit this thing with a square root. The only issue we're going to have at this point is there's going to be a plus or a minus. And when you have sine of half an angle, it looks as such. Here are our half angle formulas. Notice the similarities to your power reduction formulas. They hold the same form. They both have a 1 plus cosine for cosines, right? The sines both have the 1 minuses, so they line up very nicely together. Now, tangent has half angles. Shit, I don't know. I literally have a book next to me. I'm pulling it up and being like, all right, yeah, here we go. Tangent of alpha over 2. Here's your half angle, which you do not care about at all. 1 minus cosine of alpha over sine of alpha. And you could also use, what is it, sine of alpha over 1 plus cosine of alpha. And there's tangent's half angle, so I couldn't care less about those two formulas. Unless you do, you can go get into it. But to recap, here are your half angles formulas. And that one too, but whatever. We have our power reduction formulas. And then we got our double angles from right back here. We're going to use these 3 concepts as we move along. These will be the 3 things. We'll start playing trig equation games with it. You'll see a lot of that, trig equations, by using this. They'll also be on your test. We start building it up, making it a little bit more challenging. And that should be about it for your second exam. So you probably have like 3-4 more videos just showing you how to do stuff and not any more of the proof. So see you then.